so here we've got if n is odd. All right, so let's start with n is odd. So if n is odd, we can let n be 2k plus 1. There's a nice odd for some integral k. So let's now consider what we're interested in, the sum of n consecutive numbers. So let's consider the sum of n consecutive integers. So we would have a plus 1, a plus 2. We want n of them. So if I started at a, the nth one, see, this would be the first one, second one, third one. You can see it's got one number less. So the nth one will be with n minus 1 in it. So I'd say for sum a is integral. All right, so that's the sum of n consecutive integers. And again, you know that there are going to be n lots of a's because we're interested in the divisibility by n. So I've got n lots of a's, or an, and then what's left? I've still got all the numbers left. 1 plus 2 plus 3, you know, all the way to n minus 1. Oops. So I've still got this left. So is that divisible by n? Well, that's just the sum of n minus 1 numbers, and it's an arithmetic sequence with a difference of 1. So remember, you have the number of numbers divided by 2 for the sum. So the sum of n minus 1 numbers is n minus 1 on 2, first plus last. And you can see the first term plus the last term. The first term plus the last term gives you just n. So again, so this just gives you n there. So I'm going to have a plus n minus 1 on 2. Yeah, so it looks like it's divisible by n, but remember this inside of the bracket has to be an integer, so we have to show it's an integer. So this is where we need the fact that we've got an odd n. So if I put an odd n in there, so that's 2k plus 1 minus 1 on 2. So that is a plus, you know, 1 plus 1 minus 1 cancels out. So I just get plus k here, 2k on 2, so plus k. Doesn't look like a k. So I don't know what that is either. So I've got a plus k. So n lots of a plus k. Therefore, it must be divisible by n because my a plus k is an integer. So therefore, when n is odd, the sum is divisible by n. Now, what about when n is even? So let's go back and look at before we subbed in our odd n. So if we go back to here, you can see that if we subbed in a even n instead, so we'd go all the way through, but now we're subbing in an even, and you'd get a plus, so even would be 2k, right? So you'd get 2k for n minus 1 on 2. Now that doesn't look great. We've got a plus 2k on 2, and then you'll have a half. So you see that it cannot be an integer because of this minus a half. So this bracket can't be an integer. Therefore, our a in this case is not our sum of consecutive numbers is not divisible by n when n is even. So it was when n was odd, but not when n is even.